All right, today we're going to learn about functions and transformations of functions. We're going to learn about shifting functions, functions on graphs that move either left or right, up or down, reflections of functions, which means that functions can reflect over the x or the y-axis. And then we're going to examine even and odd functions, both with tables and with graphs. This first question we're going to look at has to do with a function that's given to us, and then it says that the other function is being transformed into something different. So um, we have the graph y equals f of x in this purple graph, and then the transformation of that y equals g of x. So the graph of the function f is the graph of function g shifted right 9 units. So this graph is the blue line, but it's gone right 9 units. Now, when we're talking about shifts on graphs, um, if we have something that, for instance, if we had something that said h of x equals x plus 9 squared plus 5, we would first graph the parent function. And the parent function is y equals x squared. And we can tell because there's a squared there and there's an x there. So when we see our parent function, then we have to figure out what's happening inside the parentheses and what's happening outside the parentheses. When we look at what's inside the parentheses next to the x, we're going to shift our function that many units in the opposite direction of what our sign is. So if we graph y equals f of x, I'm just going to do a very quick sketch here. It's going to look something like this. Y equals x squared. If we graph h of x is x plus 9 quantity squared plus 5, we're actually going to move to the left 9 units. So if h of x is green, we're going to go left 9. So this would be at negative 9. And we're going to go up 5 from our vertex. So if that was 5, this would be our new vertex, and our graph would look something like this. So that's how we can transform this original parent function into the transformed function h of x. This one doesn't give us the formula, though, for this example on the left. So let me erase this. It wants us to write the formula of f of x in terms of g. So f is the graph of g shifted right 9 units. So to write that part, we're going to write f of x equals g, the graph of g, where x is shifted right 9 units. And it's the opposite sign. It's the opposite sign inside the parentheses. We're not shifting up or down. If we look at these two dots here, we're not shifting up or down. So we're not going to plus or minus anything over here. That just stays blank. And so that's going to be our final answer. So this graph we're saying equals the blue graph. I'm going to say the purple graph equals the blue graph. Minus 9. Let's look at a couple other of these. I think if we do a few more, we'll make a little bit more sense here. So this next one gives us an equation with these. So the first one here, we didn't have an equation. Now, if we have an equation, it says that h of x equation is x minus 4 squared plus 2. That's this graph here. And g of x, we don't know what that is. But we do know that it has shifted left. It's at 4 on the vertex. It's shifted left 10 units. And it's shifted down 8 units. So we're going to write g of x. We're gonna write it like we're gonna replace the x in the h of x with x plus 10. So if h of x equals x minus 4 quantity squared plus 2, we're going to now write, well, it's going to go left 10, so we're going to write h of x plus 10 is equal to, we're just going to write x plus 10 here, minus 4 squared plus 2. But we also went down 8. So now we're going to write this as h of x plus 10 minus 8, the 8 that we're going down. And we're going to write our complete function as x plus 10 minus 4 all squared plus 2, and then minus this 8 here. Putting it all together, h of x plus 10 minus 8 is equal to, this is inside the parentheses here in the squared parentheses, so this is going to be x plus 6 quantity squared, and 2 minus 8 is minus 6. Now, what we're saying is, we're saying that h of x plus 10 minus 8 is equal to g of x. And so we just found that g of x equals that. And so that would be our answer for what g of x is. Okay. Next, we're going to look at reflecting functions. So functions can be reflected. They can be the same size, but they can be reflected over the graph. And so when we see reflections, we have to think about what is happening when there is a reflection. Is it reflecting over the y-axis? Is it reflecting over the x-axis? What's happening exactly? So we're going to get some questions that look really confusing with some of the ways that they tell us what the equation for f of x is, but really we just have to look at the graph itself. So I'm gonna put our rules over here, and we're just gonna use this this rule table to look at what's happening in our graph. So the function f is the solid line, g is the dashed line, and we know the equation for f of x, and it says what's the equation for g. And we get some multiple choice actually for this. So let me copy the multiple choice answers also. All right, so when we have a reflection over the y-axis, it's called a horizontal reflection. And that means that f of negative x is how we would express this. So here's what we're going to do is we're going to plug in f of negative x and see what we get. So everywhere we see an x in this negative 2 log base 2 x plus 1 plus 3, we're going to put a minus x. Okay, and it looks like we don't have an exact, let me see here. Make sure it's exactly the same. So this one's going to be C. So even though this part's written in a different order, that still means the same thing. So all we did is we looked at our table and we figured out, okay, it's a horizontal reflection. We're going to use this rule. And then we apply that rule, plug in the negative x for when we see x, and we determine our answer that way. Okay. This next one, let's see if we've got another example we can look at. Let's see here. Trying to find one more that's trying to find one more that has a graph for us to look at on these. Because I think it's nice to be able to see a graph that's either a vertical or horizontal reflection. Some of them are vertical and horizontal as well. Let's take a look at this next one here. So I did just kind of scroll through a couple of them to get to ones where it shows us the graph. Because I think looking at the graphing ones with multiple choice, I think you can probably do those if you see multiple choice on there with the graphs. But let's bring our rules down here. And this says, what's the equation of G? We could probably do this without multiple choice for this one, actually. But let me copy those anyway, just to have them. Okay, so it says, what's the equation of G? Well, we've got to figure out what's happening on our graph going from blue to dashed line. And I would try to figure out a point that we know that what's happening from one point that we can see for certain that it's the same other point on the other graph. And that would be those 2 points there. And so we can see now that there's a reflection over the x-axis. So we're going to use this rule. So we're going to use f or negative f of x for this. And so when we say negative f of x, we're going to multiply by -1 all of what the function is. So we're just going to say -1 times, and then write what all the other information is inside of what the function's value is. All right, the function's value inside the parentheses, excuse me. And so we can write -1 times that. Sometimes you'll just see a negative in front of the parentheses. That's a bit more common. But then we're going to distribute this negative properly. Um, let me see here. This was -2. Yeah. So when we distribute this negative, it's going to equal -1/4 x plus 2, quantity x plus 2 cubed, and then plus 2. So that's what negative f of x is. And that's the same thing as g of x, which is our dotted line. So now we've got to just go to multiple choice here and figure out which ones match. It looks like B is the right answer for this one. All right, let's take a look at another one here. Just a moment to copy this. All right, so there's kind of a lot to copy there. So I'm going to pause the recording for just a second and copy this all here. So we've got to figure out next now, we're kind of going to work in backwards order. We have the graph and we've got to figure out which graph is showing f of x going to g of x, which is the negative of the function. So that should be just like our last one, because negative f of x is a vertical reflection or a reflection over the x-axis. So if we take a point that we know for certain, this point here, if it reflected over the x-axis, it would go there. And then if we look at another point, this point, if we reflected over the x-axis, that would go there. That would make a reflection there. So we've got to look at now what's happening, which graph would show us a point at negative 6, 2, and which one would show us a point at 6, negative 2. So here and here, which graph would make that true? So it looks like C and B look very, very close. So you've got to be careful with that also. We've got to look at that middle portion just to make sure. So that's at about 2, 1. So if it was reflected, it would be 2, negative 1. Okay, so that's all. We're using 3 points now to figure out what's going on here. But it looks like graph B is going to be it for this one. It looks like it lines up with all of our dots. I'm going to put them in green actually for all of our new dots. Maybe easier to see those. So we've got the same point at negative 6, 2, 2, 2, negative 1, and 8, negative 2. Okay, so that's how you do those ones. That should be about all of them. Some of them are going to be some strange looking graphs. Don't be too intimidated by seeing graphs that look like unpredictable or have square roots or logarithms, or just following this rule set here. So if you need to, you can take a screenshot of this and say you have those rules there. Okay, so that's reflecting functions. Let's go back up here. Okay. Just want to make sure we covered everything there. Okay, the last thing we're going to talk about is even and odd functions. So even and odd functions, they also have a rule that we have to follow. Um, and let me see if I can show you guys an example here. Let's see. Here's our first example. It says, is this function even, odd, or neither? So let me see here. So if it is, here's our rules for even, odd, or neither. If it's in black here, if f of x equals, excuse me, if negative f of x, f of negative x equals f of x, then our function is even. If f of negative x is equal to negative f of x, then our function is odd. And if we do f of negative x and we get something random, like some of it became negative, some of the function became positive, then it's neither. So let's look at f of x as 5x. If we then say, well, let's see what f of negative x is, we're going to plug in negative x everywhere we see x. This one's pretty easy. It's just going to end up being negative 5x. So what happened to our function is it became negative 1 times our original. That is going to mean that it's an odd function. So we would just, as our rationale, we would just say that f of negative x equals negative f of x. And that's an odd function. I'm going to copy these rules so we can have that for our next problem. So let me just delete this part. Okay. The next part is determine if this function is even, odd, or neither. F of x equals x to the fourth minus 2x squared. Is it even, odd, or neither? So we're going to do the same thing we did before. We're going to plug in negative x everywhere we see x to determine what is f of negative x. So this is negative x to the fourth minus 2 times negative x squared. Anytime that we have something to an even power, it's going to make it positive. So sometimes if you don't put parentheses in your calculator, if you're actually putting numbers in and checking to the power 4 or something squared, your calculator might tell you the wrong answer. It's always a positive because if we look at the squared term, negative x times negative x is x squared. Okay, that's kind of a side note there. But now this is going to be x to the fourth minus 2x squared. So that is what f of negative x equals. So that is the same as our original. Those are the same. And so we would say that f of negative x is equal to f of x. And according to our rules, that means that it's an even function. Okay, let's see if we can try one more of these here. Okay, this next one, and you'll have multiple choice for these, I believe. So here's the next one. It says, and these are all the same. I just wrote the last one instead of doing copy paste. So this one says, is this even, odd, or neither? For f of x is x to the fourth plus x. So we're going to check f of negative x. Sorry about that. F of negative x. And we're going to plug in negative x everywhere we see an x. Negative x to the fourth plus negative x. And that's going to give us x to the fourth minus x. So that's what f of negative x is. Now, we don't really have a pattern for this. This one, there is no pattern. If we multiplied everything by -1, we would get negative x to the fourth minus x. But we didn't. We got x to the fourth minus x. So we didn't multiply everything by -1. And also, it isn't the original equation. So in this case, it's going to be neither. So if you're not seeing a pattern and you're seeing that some numbers changed, some didn't, that's going to be a neither answer. Okay, so that should be all of quiz 1 for unit 9 for transformations of functions. And we will look at some more information on functions for our next video, and that's going to be on scaling functions and identifying more function transformations.